Hello and welcome to our class, the cycloid. The curve of farthest descent is also called the cycloid, which is the curve traced by a point P on the rim of a wheel, such as this one. There is a point P on the rim of wheel, as the wheel rolls along a straight line without slipping. We can find that the equation of the cycloid is the same as the curve of farthest descent. Now let's see in this picture. So this is the wheel, and to begin with, let's draw a line. To avoid slipping, let's glue the ruler. Now, let's choose one point on the wheel. Now, let's begin. We choose one point P on the rim. Then, let the wheel rotate along the line without slipping. It's a little hard, but very interesting. Alright, it's like this. Now let's find the equation. So just now we have the cycloid, then now we try to find the parametric equation of that. And we add another axis. This point as the origin. So it's rotate and to this point. Suppose this point, and this point is P. And this is the original line from C to P. And now this is the line perpendicular to the x-axis. Alright, so from the origin to this point, then the radius rotate about the angle of theta. Now my question is, what is the equation for the cycloid? That means, what is the coordinate of x and y for it? Now, let's think. So x of this graph, so x is about this part, and y is about this part. Now our question is try to find x and y. So x is this part, and y is this part. So the question is to find x and y. Now you see this part x can be think is the difference of the longer part minus this part. And what is the length of this part? So now let's determine x. Because this point at the beginning, this point at the origin, and then it's rotate to this point. So actually, the arc of this part is equal to the length of this line. Alright, so the question is, what is the arc of this part? It's quite easy, right? Suppose the radius is r, then this arc is r times theta. Alright, so the length of this part is r times theta. Now, my next question is, what is this segment? Now let's try to do a triangle like this. So we found the triangle like this. So this whole angle is theta, and we know this angle is pi over 2. So this angle actually is, theta minus pi over 2. Alright, and this part, this is a right triangle again. So we can find this one is r, Then this part, we can see that this part is r times cosine theta minus pi over 2. All right, we found that. So this one is r cosine theta minus pi over 2. And to simplify it is equal to r theta minus r cosine theta minus pi over 2 is equal to sine theta. So actually this one is r theta minus r sine theta. Or simplify it like r times 1 theta minus sine theta. Alright, we found x. The next we need to find y. Y is this whole part. Y is this whole part. And from this graph you can see that y is equal to this part, that is r, plus this part, right? With the experience of x, we can easily find y. So y is this one plus this one, and this one is equal to r. So y is r plus this part. This part is r times sine theta minus pi over 2. And it's equal to r plus r sine theta minus pi over 2. This one is equal to minus cosine theta. So it's equal to r times 1 minus cosine theta. All right, now we find the equation of cycloid. Just now we analyze it. Now let's solve it step by step. Let's find the parametric equation for the cycloid. Let the wheel roll along the x-axis with P initially at the origin. Denote the center of the wheel by C. And let R be its radius. Choose for parameter the radian measures theta of the clockwise angle through which the line segment CP has turned from its vertical position when P was at the origin. All of this is shown in this figure. You see, since the length of ON equals the arc of PN and equals r theta, then x equals the length of OM equals the length of ON minus the length of MN, and equals r theta minus r sine theta, which is r times theta minus sine theta. And we can find that y is the length of MP and equals length of NR equals the length of NC plus length of CR equals r minus r cosine theta is r times 1 minus cosine theta. Thus, the parametric equations for the cycloid are like this. My drawing is not that good. Now let's see the picture from Wikipedia. Another interesting property is this. If L is the lowest point on the arc of an inverted cycloid, the time that it takes a particle P to slide down the cycloid to L is the same no matter where P starts from on the inverted arc. Thus, if several particles P1, P2, and P3 in different positions on the cycloid start to slide at the same instant, all will reach the lowest point L at the same time. This is animation of Wikipedia. And also, I have a video from my son Jonathan 4 years ago. You can see this video for this experiment. In 1673, the Dutch astronomer Christian Huygens published a description of ideal pendulum clock. because the bob swings between cycloid kicks. The path of bob is a cycloid. This means that the period of the swing is independent of the amplitude, and so the period does not change as the clock's spring unwinds. Alright, today we discussed the properties of cycloid, and we studied the fastest descent curve. I hope you enjoy it. That's all for this section. Thank you.